Okay, so get this. We're diving into quantum computing today.
Right.
Specifically, a recent discovery that has scientists really buzzing.
Oh, wait.
Imagine this atoms, the tiny building blocks of everything, literally vanishing
Oh, wow.
in the middle of complex calculations.
Yeah,
Sounds like a sci-fi movie, right?
totally.
But it's a very real problem that researchers have been grappling with for a while now.
For a while, yeah.
Luckily, a team of brilliant minds has figured out a way to detect these disappearing atoms, which is a huge step forward in making quantum computers more reliable.
Huge.
We've got some articles and research notes here,
Okay.
and you know what that means? Time for a deep dive.
Let's do it. All right. So this is a fascinating challenge.
Okay.
You see, quantum computers work with these things called qubits.
Okay.
Think of them as the quantum version of bits.
Right.
The zeros and ones that regular computers use.
Right.
But here's the mind-blowing part.
Mm-hmm.
Qubits can be both 0 and 1 at the same time.
Hold on.
Yeah.
They can be in two states at once?
At the same time.
That already sounds like we're stepping into a different reality.
Exactly. And that's what gives quantum computers the potential to be exponentially faster
Wow.
than the computers we use every day. They can explore countless possibilities simultaneously, which is incredibly powerful. But there's a catch.
Okay. I'm sensing a but coming.
Well, one of the leading approaches to building quantum computers uses neutral atoms, literally individual atoms,
Okay.
as qubits. But these atoms are, to put it mildly, a bit squirrely.
Squirrely, what do you mean?
I mean, they have a tendency to, well, disappear.
Oh.
Even the slightest temperature fluctuation
Yeah.
or stray magnetic field can cause an atom to escape from the system. And when you're dealing with millions of these atomic qubits,
Yeah.
losing even a few can completely derail your calculations.
Oh, wow.
It's like trying to bake a cake and having key ingredients vanish mid-recipe.
So you're telling me that these super powerful quantum computers can be thrown off by something as simple as a slight temperature change?
Yeah.
That seems like a major design flaw.
It's definitely a significant hurdle.
Yeah.
Imagine you're running a complex simulation on a quantum computer,
Okay.
and suddenly, poof, one of your qubits vanishes.
Wow.
The whole calculation becomes essentially useless.
Oh, no.
That's why this new detection method is so groundbreaking. It allows scientists to know when an atom is missing
Okay.
without actually having to directly observe it, which in the quantum world is a big no-no.
Okay, now I'm really intrigued.
Yeah.
We know these atoms are vanishing, and it's a big problem.
Right.
But how do you detect something that's literally disappeared? It's like trying to find a ghost.
Right. You can't just look for a missing atom in the quantum world.
Right.
Direct observation would disrupt its delicate quantum state.
Yeah.
And remember, maintaining that state is crucial for the whole thing to work.
Right.
So the researchers came up with a clever workaround.
All right, lay it on me. What's the secret?
They use a second atom, a sort of buddy atom, as a quantum sensor.
Okay.
This buddy atom is entangled with the atom they want to track.
Entangled. Now, there's another big quantum word.
It is. What
Yeah.
does that even mean?
Good question. It's one of the weirdest and most wonderful aspects of quantum mechanics.
Okay.
Entanglement is when two particles become linked, no matter how far apart they are.
Really?
They share a destiny, so to speak.
Okay.
If you measure the state of one entangled particle,
Yeah.
you instantly know the state of the other.
Whoa. It's like they have this invisible connection, a quantum hotline.
Exactly.
So how does that help with the vanishing atom problem?
Here's the ingenious part.
Okay.
By carefully monitoring the state of the buddy atom, researchers can indirectly detect whether the target atom is still present or has gone AWOL.
Oh.
They don't need to directly observe the target atom, which, as we said, would mess everything up.
Right.
It's like having a secret signal that tells you if your partner in a game of hide and seek is still hiding or has snuck out.
That's incredibly clever.
It is. So they've basically created a quantum alarm system that goes off when an atom decides to take an unauthorized break.
You could say that, and the best part, this method is incredibly accurate.
Really?
The researchers achieved a detection rate of 93.4%.
93.4%. That's amazing. But hold on, I have to ask.
Okay.
This solution seems so intricate and complex. How on earth did they even come up with this idea?
That's where it gets even more interesting.
Okay.
The lead researcher, Matthew Chow, wasn't even specifically looking for this solution. He stumbled upon it by pure chance.
What?
While debugging some code, talk about serendipity.
Wait, so he accidentally discovered one of the biggest breakthroughs in quantum computing while trying to fix a bug.
It happens.
That's like finding a winning lottery ticket stuck to the bottom of your shoe.
Exactly. It just goes to show you that sometimes the most significant discoveries happen when you least expect them.
This is already blowing my mind, and we're just getting started.
Yeah, right.
But before we go too far down the rabbit hole,
Yeah.
I think we need to take a step back and make sure everyone's on the same page. I know, I'm already feeling a little lost in the quantum weeds.
A little bit. Yeah.
So for our listeners who might be new to this whole quantum computing thing,
All right.
let's do a quick recap. What are the key things they need to understand before we jump into the deeper implications of this discovery?
Absolutely. Let's do a quick Quantum 101. The main takeaway is that quantum computers are fundamentally different.
Yeah.
From the computers we use every day, they leverage the bizarre rules of quantum mechanics
Right.
to perform calculations in ways that classical computers simply can't.
Right.
This opens up a world of possibilities
Okay.
for solving problems that are currently intractable, like designing life-saving drugs,
Wow.
creating new materials with unheard-of properties,
Yeah.
or even cracking the codes that protect our online information.
Okay, so we've established that quantum computers are potentially revolutionary,
They are.
and that using individual atoms as qubits is one way to build them.
Yeah.
But before this breakthrough, how were scientists dealing with this whole vanishing atom issue?
Right.
Were they just crossing their fingers and hoping for the best?
Not quite. They had some strategies, but they were far from ideal.
Okay.
One approach was to try and physically trap the atoms more securely,
Okay.
using things like lasers or magnetic fields.
Yeah.
But this added complexity and limited the flexibility of the system.
Okay.
Another approach was to try and compensate for the lost atoms
Right.
by estimating their probability of disappearing and adjusting the calculations accordingly. But this introduced a lot of uncertainty,
Oh.
kind of like trying to navigate with a blurry map.
So it sounds like this new detection method is a game changer.
It is.
Not only can they detect a missing atom,
Right.
but they can do it without disturbing the delicate quantum state of the other atoms.
Exactly.
It's like having a quantum detective who can gather evidence without contaminating the crime scene.
Precisely. And this opens up new possibilities for designing more robust and reliable quantum computers.
Okay.
It allows researchers to focus on scaling up these systems without being constantly hampered by the fear of losing qubits.
So it's not just about finding a missing piece, it's about strengthening the foundation of the entire quantum computing architecture.
Exactly, the critical step
Yeah.
towards building larger, more powerful quantum computers
Right.
that can tackle the world's most challenging problems.
You know, it's fascinating to me that Chow stumbled upon this discovery while debugging code.
It is.
It makes you wonder how many other hidden gems are lurking in the data,
Yeah.
just waiting for someone to notice them. It's a testament to the importance of observation,
Solely.
curiosity, and maybe even a little bit of luck
And luck.
in scientific research.
Absolutely. And it highlights the importance of creating an environment
Yeah.
where researchers are encouraged to explore, experiment,
Mm.
and even make mistakes. Sometimes the most groundbreaking discoveries come from the most unexpected places.
It's like that famous Louis Pasteur quote, "Chance favors the prepared mind."
Exactly. You have to be open to the possibility of the unexpected, to questioning what you think you know.
Right.
And that's especially true in a field like quantum mechanics, where the rules of the game are so fundamentally different
Yeah.
from our everyday experience.
Speaking of those rules, let's dive a little deeper into how this new detection method actually works.
Sure.
We talked about using a second atom as a quantum scale,
Right.
but what does that mean in practice? How do you weigh an atom without looking at it?
It's not magic,
Yeah.
but it is pretty ingenious, as I mentioned earlier.
Okay.
It relies on this bizarre phenomenon called entanglement.
Right.
Imagine two particles linked in such a way that they share a destiny, even if they're physically separated. Measuring the state of one instantly affects the state of the other,
Yeah.
no matter how far apart they are.
So they're like quantum twins connected across space.
Exactly. In this case, they entangle the scale atom.
Mm.
With the atom they want to detect, if the target atom is present, the entangled scale atom will behave in a very specific way.
Okay.
If the target atom is missing, the scale atom will behave differently.
So it's like having a secret code between the two atoms.
Right.
By observing the behavior of the scale atom, they can indirectly determine the presence or absence of the target atom.
Precisely. And the beauty of this method is that it doesn't require directly observing the target atom,
Right.
which, as we discussed, would disrupt its quantum state.
It's like a quantum detective gathering clues without disturbing the crime scene.
I love that analogy, and the implications of this discovery extend far beyond just detecting atom loss.
Okay.
It opens up a whole new toolkit for developing error correction techniques, which are essential for building large-scale, fault-tolerant quantum computers.
So it's not just about plugging a leak, it's about building a stronger foundation for the entire quantum computing infrastructure.
Precisely. This breakthrough brings us one step closer to realizing the full potential of quantum computing.
Yeah.
With all its mind-boggling possibilities.
It's amazing to think that something as small as a vanishing atom could have such a profound impact
It is.
on the future of technology.
It truly is. It highlights the importance of investing in fundamental research,
Yeah.
even in areas that might seem obscure or esoteric at first glance.
Right.
Sometimes the most groundbreaking discoveries come from the most unexpected places.
This has been an incredible journey so far.
It has.
And I'm already feeling like I need a quantum physics degree to keep up.
Me too.
But before we get completely lost in the quantum realm, I think it would be helpful to ground this discussion
Okay.
in some real-world examples.
Yeah.
We've talked about the potential of quantum computing in a broad sense.
Right.
But what are some specific ways this technology could impact our everyday lives?
That's a great question, and it's one that scientists are actively exploring. The applications of quantum computing are vast
Okay.
and still being discovered. But let me give you a few examples.
Please do. I'm eager to hear how this mind-bending technology could translate into tangible benefits for people like me,
Okay.
who don't spend their days pondering the mysteries of the quantum world.
Well, one area where quantum computers are expected to have a huge impact is medicine. Imagine being able to design drugs
Wow.
with pinpoint accuracy targeting specific diseases at the molecular level.
That would be a game changer for so many people battling chronic illnesses. What else can we expect from this quantum revolution?
Another exciting area is material science. Quantum computers could help us design completely new materials with tailored properties, things like super strong but lightweight alloys for building more efficient vehicles, or materials that can conduct electricity with zero resistance, leading to incredibly efficient energy transmission. The possibilities are really endless.
It's like having a molecular level 3D printer that lets us design the materials of the future. So we've got life-saving drugs and revolutionary new materials. What else is on the quantum horizon?
Well, quantum computers could also revolutionize fields like finance and artificial intelligence. They could help us develop more sophisticated financial models to better manage risk or create AI algorithms that can learn and adapt in ways that are currently impossible.
It sounds like quantum computing has the potential to touch almost every aspect of our lives, from the medicines we take to the way we interact with technology. It's both exciting and a little bit daunting to think about the scale of the change that could be coming.
Absolutely. It's important to remember that this technology is still in its early stages, and there are many challenges yet to be overcome. But the progress being made is incredibly encouraging, and this new discovery for detecting vanishing atoms is a major step in the right direction.
It's amazing to think that just a few decades ago, quantum computing was a purely theoretical concept confined to the pages of scientific journals. Now we're seeing real-world breakthroughs that are pushing this technology closer to becoming a reality.
It's a testament to the power of human ingenuity and the relentless pursuit of knowledge, and it's a reminder that the journey of scientific discovery is full of twists and turns, unexpected detours, and sometimes even happy accidents.
Speaking of happy accidents, I'm curious to know more about the implications of this discovery beyond just fixing the vanishing atom problem you mentioned, that it opens up new possibilities for error correction. Can you explain what that means and why it's so important?
Sure, error correction is crucial for building any kind of reliable computer, whether it's a classical computer or a quantum computer. Errors are inevitable, especially when you're dealing with systems as complex and delicate as quantum computers. But with clever error correction techniques, you can essentially build redundancy into the system so that even if some qubits go haywire, the overall computation can still proceed accurately.
So it's like having a backup system that kicks in if something goes wrong.
Exactly. And in the world of quantum computing, error correction is even more critical because of the fragile nature of quantum states. Even the slightest disturbance can cause errors to propagate through the system, potentially derailing the entire computation.
So this new method for detecting missing atoms is like having a more sensitive early warning system for errors.
Precisely by quickly and accurately detecting when a qubit is missing. Researchers can implement error correction measures to prevent those errors from cascading through the system. It's a major step towards building fault-tolerant quantum computers that can reliably perform complex calculations.
It sounds like this discovery is not just a fix for one specific problem, but a fundamental building block for more robust and reliable quantum computers in the future. It's exciting to think about the possibilities that this opens up.
It is, and it underscores the importance of continuing to invest in fundamental research, even in areas that might seem esoteric or abstract. At first glance, you never know where the next breakthrough might come from, or what seemingly unrelated field it might impact.
It's a reminder that the world of science is interconnected in ways we might not even fully comprehend yet. A discovery in one area can ripple outwards, sparking innovation and progress in fields that might seem completely unrelated on the surface.
Exactly, and that's one of the things that makes science so endlessly fascinating. There's always something new to discover, some new mystery to unravel, and who knows what amazing technologies and breakthroughs await us in the future, all thanks to the tireless work of scientists who are driven by curiosity and the desire to understand the universe around us.
It's an inspiring thought, and it leaves us with a final thought-provoking question for our listeners. If even the tiniest particles like atoms can behave in such unexpected and mind-boggling ways, what other mysteries might the quantum world hold? What other seemingly impossible feats of computation or technology might become possible if we continue to delve deeper into this realm of infinite possibilities? And on that note, I think it's time to wrap up our deep dive into the world of vanishing atoms and quantum computing. I don't know about you, but my brain is officially full in a good way. Keep those minds curious, folks, and we'll catch you next time on The Deep Dive, where we'll explore another fascinating corner of the world of science and technology.